today. It was before 7 a.m. and there were a lot of you just sitting outside the door. So we really appreciate your enthusiasm and your interest in STEM. And today I have to say, you guys are in for such a treat because this woman is an amazing woman. The few conversations I've had with her, every time I talk to her, I just feel so inspired to do more and do more for my community and more for STEM because her experiences, her passion for social justice, her passion for students is just unbelievable. So I have the privilege and honor to introduce our former First Lady of Tulsa, Dr. Kathy LaFortune. So please let's give her a round of applause.
Thank you all so much. I can't believe you're here at 7 o'clock in the morning. I mean, I thought, you know, I've read a lot of research about when teens would rather start school, and that would be about 9:30 or 10. So the fact that you're here, I really appreciate you being here today. I want to talk to you about getting into engineering careers. How many of you are thinking about an engineering career? Okay, so good. What I want to tell you about engineering in my experience, I am not an engineer right now. I was an engineer for a while. And I ended up working at an incredible place that I want to tell you more about this morning. And that place was Bell Labs in New Jersey. But I want to start off with why I think you guys might want to consider engineering as a career as far as college is concerned, and then maybe down the road you'll get into something else like I did. So just to tell you a little bit about my own background, I went through public school and then I went through Holland Hall High School, and one of my counselors said to me, why don't you consider going out of state to go to college? And I never really thought about that because I grew up in Tulsa, and those of you who've grown up in Tulsa, or those of you who have moved here from some other place, that puts you in a little different perspective because I had never been away, you know, other than going on vacation, never moved anywhere else. And so I thought, well, why not? So I guess one of the things I want to encourage you to think about today is looking around the country at other schools that you might want to attend, because there are a lot of really good engineering schools that we're going to talk about and that you could apply for. So something to think about. I don't know how many of you are juniors, seniors, sophomores? Is most of the group, are you seniors, juniors? Juniors. Okay, so you're thinking about this already. But the thing about engineering that I think is so helpful in your whole life as you go through life is the fact that it teaches you how to be a critical thinker, no matter what career you get into. My career, I ended up going to college at Duke University, and I majored in mechanical engineering. And I started off in mechanical, and I kind of diverted into what we call metallurgy, which is study of properties of metals and polymer science and material science. And the reason I got so fascinated with that is because everything in our world is made of something. And you look around and you think, well, why is this particular material shiny? Why is this particular material, why is it dull? Why do certain materials have what we call ductility? Why can you stretch some things and they break, and other things you can stretch and stretch and stretch and they don't break? So the whole idea of material science and metallurgy was just fascinating to me. And I hope that some of you take this on as a career because it is an amazing career. And back when I was going to college, there were not a lot of places in Oklahoma to use that knowledge. And basically it's like the East Coast or the West Coast is where you get to use material science and metallurgy. But that's changed a little bit in Oklahoma. There are some research facilities now that study roads and the way roads are built, because our weather in Oklahoma is so vacillating that think about how our roads are built in Oklahoma. We have to withstand 110-degree weather. We have to withstand 10-degree weather. So trying to come up with materials that will withstand our weather pattern is really difficult. So when you think about going to college and having some sort of summer job, I want you to think about doing something really different, like applying to a company where you could work as an intern at a research facility of some kind, because that is the best preparation for you in life, in trying to figure out your own career. Like, what do you want to do? How do you know you want to be an engineer at this point? How do you know you want to go to medical school? How do you know you want to be an attorney? Well, I kind of took a long route through education. I actually ended up getting my engineering degree, then I went to law school, and then down the road, I ended up going and getting a PhD in forensic psychology, actually clinical psychology, and I'll tell you why that is in a little bit. But another thing you have to think about too is that you will change jobs about 7 to 12 times in your lifetime. And if you get on the internet and you start looking around at job changes, they'll tell you, well, the Bureau of Labor Statistics, they don't keep track of career changes, but they do keep track of job changes. And, you know, my parents' generation and your grandparents' generation, your grandparents probably worked for a company for 30 years. And that's not true anymore. That's just not true. People change jobs frequently. And in my own career, I've gone from being an engineer to a lawyer to a psychologist. And you're thinking, why did you do that? What's the point of that? Well, I think for me, part of the point of getting different degrees is that I have a really interest, a curiosity about science and about, it's moved into a curiosity about the brain. And there's a lot of research right now going on about brain, the brain development, healthy brain development, and that sort of thing. And the good thing about my background in engineering is that it's problem solving. That is what you're doing from day one. You're being a problem solver. And for me, like I mentioned to you, the most interesting of all fields for me was metallurgy and polymer science, because I wanted to know why things fail. I wanted to know why things break and how we can fix them. And now I just happen to be in the field of forensic psychology, which is studying why people fail and how we can fix them. And so I know that sounds unusual for somebody to go from engineering to psychology, but actually my engineering degree helped me more than just about anything in just understanding the way things work. So within engineering, there are specialty areas that incorporate other disciplines. And for example, at Duke University, they have a degree in biomedical engineering. And Duke has a really good medical school, as a lot of other schools do, that you then can incorporate the medical field with engineering. So you learn how to make devices such as parts for people that have prosthetic issues, people that have lost limbs. And if you think about the people coming back from Afghanistan and Iraq who have lost parts of their bodies, the whole idea of BME is really important. Now, moving right along, if you think about looking at where you could go to school, I want you to think about where, all across the country, all these different areas of the country where you could get a degree in engineering. And these are the schools that are the top 30, according to U.S. News and World Report. So think about where all these places are. Massachusetts Institute of Technology, Berkeley, CIT, Carnegie Mellon, University of Michigan at Ann Arbor. All these different schools have certain specialties of engineering that are really important. All right, so why are summer jobs so important if you're in engineering? Because if you think about where you could work during the summer, you could work at the mall, you could work at a sports place, but I had an opportunity in 1979 to work at McDonnell Douglas, which they had a huge hangar out by the airport. And in 1993, they actually shut down this hangar at McDonnell Douglas. But one of the things they were working on at the time was an elliptical fuel tank. And if you think about an ellipse, what does an ellipse try to do? If you put stress on it, tensile stress from the inside, it tends to go round. And so what they were trying to do was figure out how to make this ellipse strong enough so that it didn't become circular, because they had only this much clearance from the wing of a plane to the ground. So they wanted to figure out how can we make this ellipse withstand filling it with fuel so that it doesn't become circular. So I'd been at McDonnell Douglas about 2 weeks, and this was right after we got out of school in May, and I came home and had about a week off. And I go to work for McDonnell Douglas, and May 25th, it's a Friday, it's Memorial Day weekend, and we're all sitting there at work, and this has been, obviously, it's been a long time ago, right? So we're sitting there at work, and there are no cell phones. We have a radio, right? We have maybe a small TV, and all of a sudden, the whole room, this huge room that is as big as this library, is filled with people and engineers all across this room. And we get this phone call about this crash. And it was the DC10. It's the largest airline crash in the history of the United States. And I'm sitting there, and I'm just a little intern, and I'm looking around the room, and I'm thinking, okay, what's everybody going to do now? And this plane had 277 people that were killed instantly, and the room just went dead, silent. And actually, this was one of the most interesting and most life-changing experiences for me, because I suddenly realized that what I did in school as an engineering student really mattered and could matter. So it wasn't just about sitting there writing equations and coming up with answers to problems. It was, this is what could happen if you do it wrong. And so everybody was really worried about this, and obviously, and just people were crying, and what they determined was, and basically the engine fell off the plane. And if you look at pictures of the plane on YouTube or Facebook, or on the internet, what you're going to find is that the plane was just vertical like this. These are the wings. It was vertical because the engine just fell off. And so these people crashed and everybody passed away. And then what they found, though, was that American Airlines was at fault. It wasn't the DC-10 itself, it was the way they had maintained it. So what happened was, all these people, all these engineers in the room were like aghast and crying, and everybody was really upset, and it was a failure, a huge failure. So what did they do? They created these little buttons, these tiny little buttons. I have some at home. I should have brought them today. I still have them. I don't know why. But it was such a meaningful experience for me. And what they did, they created these T-shirts that also said, "I'm proud of the DC-10." And it was the first time that, just being an intern, sitting in a room with all these people, that I watched these people come together as engineers in a company that became very proud of what they had done, what they had tried to do, and found out that it was not their fault. So this is one reason why working at a summer job in a company like this is so important, because you learn so much. You learn about how people work together to overcome tragedy. And the interesting thing about material science and failure analysis is highly related to material science, because if you think of things that fail, anything that fails, like a hammer that you buy at the store that breaks, and I've had them too, and where you go to the store and you buy this hammer, and then You use it and all of a sudden the handle breaks in two or something. It's all about looking at why things happen, why things don't happen, why things fail, why things keep from failing. And getting a summer job can introduce you to some of those things that people that are engineers work on every single day. So if you go to work for a company in the summer like McDonnell Douglas, which is on either coast now, it's important for your job resume, your CV. When you get out of your college experience, you want to have some of these things on your resume that can help you get into graduate school, because graduate school for engineering is really the epitome of really being able to get in there and do things that are important. It's important for networking. Some of the people that I met at McDonnell Douglas 30 plus years ago, I still know. Some of the people I met at Bell Labs 30 years ago, I still know and keep in touch with. And it's important for incorporating into other careers. Now this is a picture of Murray Hill, which is in New Jersey, and this is the place where it's just an amazing place. And the reason I'm telling you about this place is because I want you to think outside the box and think about going to some of these places during the summer and having an experience where you are with some of the top engineers and scientists in the entire world. In fact, they have at Murray Hill, which is Bell Laboratories, and you think about your telephone, your cell phone now, was invented by Alexander Graham Bell. And he went and started a small laboratory that turned into this. They have a Nobel Prize park because they have about 8 Nobel Prize winners that have come out of Bell Labs. And I just want you to think really intently about maybe applying to Bell Laboratories. If you're an engineering major, they have all types of engineers that work there. They have metallurgists, they have electrical engineers, they have civil engineers, they have, it's the most amazing place you could ever imagine. And as it's described in this picture, this is where the world's leading mathematicians and physicists and engineers and astronomers are all from. And I remember when I walked in for the first time, the interesting thing about it was they will pay for everything for you for the summer. They will find you housing, they will take you to work, they will plan weekend events like in Manhattan where they'll take you to Broadway shows, they'll take you to picnics, they'll take you to the beach. They truly take care of their student interns. And it was just an amazing experience because you get off the plane, somebody meets you, they take you to Bell Labs, you live at Rutgers University in a dorm situation with everybody else, and these kids are from all over the country, from MIT, from UC Berkeley, from California Institute of Technology, amazing places where people have gone to school and done amazing things. And I felt very fortunate to even be in the same room with these people that I was working with. The interesting thing about Murray Hill is that you have a lot of freedom. They basically, give you a desk, they give you a lab, you work with a mentor on whatever issue you're interested in. My issue when I was there, the topic was to look at telephone receiver magnets. And I know that sounds not very exciting to some of you, but if you think about why we're able to use our cell phones, that's the reason we're able to use cell phones, is because of these different properties of telephone receiver magnets, and thinking about how we take in sound, how we talk to others from cell phone to cell phone. It's all based on, most of the technology came from Bell Laboratories. The interesting thing about it is when you walk in, they have a museum that has the first transistor. And think about the importance of the transistor, which we don't really, I mean, this was invented in the 40s, right? If we hadn't had the transistor, we wouldn't have computers, we wouldn't have cell phones. There's so many things that would not be available to us unless we had the original transistor invented by William Shockley, who was one of the scientists at Bell Labs. They do optics, wireless and wire broadband, IP routing, virtualization. If you think about virtual reality now and the masks that you can buy and enter into that virtual reality, it was all created at Bell Labs by all these different scientists. And so I just want you to think outside the box about where you could work during the summer, what kind of jobs you could get so you could interact with really amazing people. The original Telstar satellite, one of the first satellites, was created there. When I walked into the museum originally, they had a tiny little chip that was in a big lucite case. And I thought, what is that? Because this is 1980, right? This is a long time ago. And it turns out that it was the microchip that stored the New York City phone book. And everybody went, oh, wow, that's really cool. Nowadays, that's nothing. But back then, that was a really big deal. So think about possibly applying to Bell Labs. This is one of the summer intern descriptions that I downloaded from the website for you, just to think about. When you come out of college, you can be employed as a summer research associate or summer intern. And for example, this one deals with the connectivity lab, and it talks about what kind of degree is preferred, but there's all kinds of different internships that you can apply for at Bell Labs. For example, if you read through here, our researchers are continually massively scaling the capabilities of networks from the data center to the end device to change the way we live and work by inventing breakthrough technologies to make networks and systems faster, smarter, and greener. So that's what we're always thinking about, isn't it? Is a system that is faster and smarter and greener. So that's just a little bit about Bell Labs. Now this is a guy named David Eagleman, and he is actually a researcher. He's been at Rice University for a long time, but he has studied the brain, and if we ever figure out exactly how the brain works, we'll understand everything about how we behave with one another. Failure that we have now because we have all these different materials. The cause of most structural failures generally falls into one of the following categories: negligence during design, construction or operation of the structure, or application of a new design or material which produces an unexpected or undesirable result. This book is an amazing book because it talks about what we call fail-safe design. If you think about traveling over that bridge, coming from Tulsa to Jinx, how did they do that? How did they design that bridge to last over time? How did they sit down and start to come up with a plan to make sure that that bridge does not collapse? How long will that bridge last? We have a lot of bridges in Oklahoma right now that need to be repaired. And so the whole idea of fracture mechanics and failure analysis would come, and that's what they do. They go around the state and they look at different bridges and they assess them for their present safety. And that's what this whole career is about. But in my own career, coming out of failure analysis and working in metallurgy, I moved into like I told you before, into the subject of studying human failure. But it's a completely different study in some ways because it involves human behavior. And human behavior, unlike a bridge or a road or or a molasses tank has a lot more intervening variables that have to be studied and they can't be predicted. One of the things I do now is what we call risk assessment. You're looking at human failure. You're looking at human behavior, human violence. And so one of the things we try to study is the whole concept of looking at a person and figuring out, will they be violent? In what particular setting will they be violent? And how can we put a protective factor around that person to make sure that they don't become violent again? If you think about major mental illnesses such as schizophrenia, bipolar illness, major depression with psychotic features, there are a lot of things that people do in life that become a problem for the rest of us. And so we try to figure out how to prevent human failure from happening. One of the things we have in the state of Oklahoma is what we call the insanity defense. The insanity defense deals with the fact that people at certain times in their life might not know the difference between right and wrong, and they might not understand the consequences of their actions. And so looking at human failure, why people do things what they do, this is what one of the things that Dr. Eagleman does, is study brain injury, study brain failure, study how people react in certain situations, why some people with schizophrenia do worse, why some people do better. And it's an amazing field, the whole field of failure analysis. But honestly, I think if I hadn't had the background in engineering to think about, critically thinking about why things fail, and then translating that to why humans fail in some cases, it's a very different but also very similar concept. Yes, ma'am?
Whenever you're talking about Dr. Eagleman studying trauma, does he study just the physical trauma to the brain or also the emotional and situational traumas?
The emotional and situational. That is why it's so much more difficult to do failure analysis with people, because you're dealing with things that are intangible, right? When you think about all the people coming back from the wars in Iraq, Afghanistan, think about the trauma, the emotional trauma that some of these people underwent. So they're back in Oklahoma. They're trying to work. They're trying to get back with their families, and yet they have this emotional trauma that actually now we know that emotional trauma changes the brain. It actually changes the physiology of the brain. If you think about kids from 0 to 4 that have experienced severe trauma, it actually changes their brain development. And it starts in what we call the amygdala, which is the center of emotion. And so if your brain at a young age is subjected to severe trauma, and it goes straight to the amygdala, which is the center of emotion because you're trying to react to a situation, your frontal lobe does not develop the way it should. And so that is one thing that he studies as well, is that emotional trauma. So questions about any of this, or anybody? But if you have questions about getting a degree in forensic psychology, I would love to speak with you, because it's totally, it's a totally different field, but it's really fascinating, and we've learned so much in the last 10 years about brain development that is going to change the way that we use medications, that we use therapy. For example, we know that in depression, if you have moderate depression, you can go to a therapist and have the same result as you would with medication. And so why wouldn't we? It's in many cases it's the medication, but it's the therapy. So anyway, have a wonderful day.